Hi guys, good morning. Welcome to the first episode of MATHEMATCS. This day we are going to discuss about general mathematics. Again, please don't forget to like and subscribe, the hit button, okay? So our first lesson is all about piecewise function. So piecewise function was first introduced by Wilhelm Gottfried Leibniz. So after he introduced it, it was further developed by Leonhard Euler. So there was a great impact on piecewise function. And then someone would ask me, Sir, why is that called piecewise function? It's very simple. Because this function is made up of pieces. Okay? So let's take a look at our example. So, alright. Let me see if it would fit. Okay, let me adjust my camera a little. Okay, so how do we write the following as a single function? When x is less than 2, it gives x squared. When x is exactly 2, it gives 6. When x is more than 2 and less than or equal to 6, it gives 10 minus x. Okay, so one of the greatest implications of piecewise function is it affects many industries. Let's say, for example, we have this fare in buses, in jeepneys, and also in any cost, in any fees, etc. Okay, so first, after we understand the problem, okay, that's the very first important thing to do. We need to understand the problem, and then we are going to write it as a function, and then we are going to graph it. Okay, so first let us analyze the first given. When x is less than 2, it gives x squared. Alright. So since this is a piecewise function, we will just denote it by f of x. Okay. So first we are going to write the first given here above. So when x is less than 2, it gives x squared. So it is simply x squared. Okay. So we are going to write our constraint here. We have if when x is less than 2. So we will write here if x is less than 2. Okay, next, when x is exactly 2, it gives 6. So it's just 6. And we will write if x is exactly 2. So when we say it's exactly, it is equals. Alright? So if x is exactly 2. Alright. Last one. So we have here when x is more than 2 and less than or equal to 6, it gives 10 minus x. So we will write here 10 minus x. And if x is more than 2 and less than or equal to 6, so it's quite lengthy. So we will just write if x is more than 2, so we will write a greater than sign, more than 2, and alright, how do we write this? And okay, I will just write it below. And x, and we have less than or equal to 6, so we will write x is less than or equal to 6. Okay, so to make this a complete piecewise function, we are going to write a bracket here. Okay, and this is our piecewise function for this problem. Okay, so since we already have our function here, we are going to graph it. Okay, so I have already prepared my little graph here. So first we will graph x squared. Okay, so in graphing this, since this is a quadratic equation, we can just actually set some table of values so that we can find what our points are. So we will just write here something like y and x. Okay, so since this is quadratic and this is squared, our graph would be more on like parabola. Okay, parabola opens upward because it's positive. So I am assuming that my function is y. So when my y is 1, okay, so when my y is 1, how much would my x be? Let's say 1 equals x squared. So square root of both sides, it will also be 1. Okay, so it will be plus and minus 1 because it's a square root. Next, how about if my y is 2? Of course, it would also be 2 equals x squared. It will be square root of 2. Okay, so that one is an irrational number. How about 3? So when it is 3, it will be a square root of 3. Okay, so let's graph it. Okay, so we have when my y is 1, when my x is positive 1. Okay, so we will have there this one and here. Okay, so we will have this at our origin, and then we have square root of 2. Let me check. Okay, it's 1.4. So 1.5 somewhere here and 2. Okay, I'm just assuming things around. Okay, next is square root of 3. How much is square root of 3? It's 1.7. It gives me 3. Alright, so remember that we have here less than 2. Okay, so since it is less than, always remember guys that when we have this sign such as less than, greater than, it will produce an open dot. So an open dot means it is not closed in that point, it is open. Okay, so we will write our point somewhere here. It's open. Okay, it's not closed. Next we have 6. Oh, it's very simple. So my x would be alright, it will be just 6, right? So it is alright. For our second function here, we have if x equals 2, our function is 6. So we have 2 here, and we will rise up to 6, and that will be a solid one. Okay, because it is equal. So if we have these signs equal, less than, or equal to, greater than, or equal to, it will be a solid line, or we have that sign later in the domain, and this will be for the open. Okay, last one. So we have 10 minus x. Okay, in this point we can actually just have table of values, but it will be pretty much easier if we are going to use our slope intercept form. Okay, so we have our in this form. Remember that this is the slope and this is the y-intercept. So slope is given by rise over run, and we have our y-intercept. Okay, so since we have our so if we are going to rewrite that into mx plus b form, it would be y equals negative x plus 10. So we'll start our y-intercept at 10. Okay, so we will start it at 10. Okay, 10. So we have 10, and then rise negative 1 and run 1. So negative 1 run by 1 point. So if you're not contented with just 2 points, you can further make it into 3 points. Negative 1, okay, and run 1. Okay, so I'll just connect it. Okay, connect. Alright, so alright, I forgot this thing. If x is greater than 2. So if x is greater than 2, okay, I see my x here. Okay, I should write an open. That should be open, guys. Okay, and then I have this less than or equal to 6. Oops, it didn't reach my 6 yet. Okay, assuming that we have reached this point, so we will write a solid 1 for that. Okay, so it's solid and open. This is for our 10 minus x. And this is for our 6. And this is for our x. Okay, so see you in my next video for the real world problem of this.